So for example number 8, I want you guys to tell me what this is. If I evaluate, notice the term that I used was evaluate. Okay. What type of integral is that? Trying to use the fancy words that Mr. Adams uses. What are the different types of integrals? I'll give you a clue. Definite or indefinite?
Definite.
Okay, good. That's right. It is definite, but why?
Because the boundaries are from
Because we have a boundaries. We're going to be able to get a number. We won't have a plus c at the end. Does that make sense?
Yes.
Okay, good. All right, so now, what is the relationship between tangent and secant squared?
Because secant is.
Sure.
Because there's the connection with the derivatives and the antiderivatives.
Right. So you're thinking the right thing. You're trying to sound fancy like Mr. Adams. You could have just said, I think one is the derivative of the other. Right?
I was trying to think of which one, what it actually
Which is which, right?
Yeah.
So when the problem is rigged up like this, what does that mean we could do? Because right now it's difficult to find the antiderivative, but I could do something. And I want to remind you that this section is on substitution.
Substitute with its derivative.
Yeah, so we have to arbitrarily choose something to be u. What would you choose? Tangent or secant squared?
Well, tangent.
Okay. All in favor? Well, let's not do that. The majority of you guys said tangent. Why?
Because we're going to have to take the derivative of u.
Mhm.
So secant squared is a derivative. So I would just make things more complicated.
Yeah. Now, if you had chosen secant squared to be u, and you will when you do your homework, you're going to choose the wrong one sometimes. You'll find, oh wait, I can't take the derivative of secant squared very easily, and then you'll come back and figure out the tangent should be your u. So, yeah, so this is kind of complicated. We're going to use u substitution, right? So then du dx, and Mr. Adams is using all the notation now that I think you guys have the hang of it. All right? But I can't ignore this dx. So what I'm going to do is I'm going to let du equal, if I multiply both sides of this equation by dx, I get secant of x squared dx, right? Algebraically speaking. So now I'm mathematically, legally correct. So all of this will be replaced with what? Du, and this will be replaced with u. So we're going to take the integral from 0 to pi over 3 of u du. Well, that's pretty easy. What's the antiderivative of u to the first power?
U. No? 1/2.
Yeah, so if I let's just think this through for a second. And I'm going to try to ignore these two because those numbers will change because these are the boundaries for x. So there's two ways to address that. Those are the boundaries for x, and I change the function to u. I could change those numbers by plugging them into whatever u is, or I could do my antiderivative with the u substitution and plug back in the x function when I'm done with the antiderivative.
Let's do that.
Let's do that. That's a good call, right? So I'm going to say that this would be u squared all over 2, correct? Is that right?
Yeah.
If I take the derivative of that, will I get u to the first power? Yeah. Just toss 2 to the front. 2 divided by 2 is 1. Then you subtract the 1. So that's it. So now the antiderivative of this is u squared, but u was tangent, so I've got tangent of x squared But now, because I've rewritten it as a function of x, now I can use the original boundaries. Okay? So now to evaluate this, using the fundamental theorem.
Wait, why'd you get rid of over 2? Oh.
Oh, I shouldn't have. You're correct. I just got, well, because my mind goes faster than my hands and my lips. But you're correct. The two, we can't ignore that too. It doesn't go away. So now what I'm going to do is I'm going to take the upper boundary. Is it really time to go? Let me just finish this.
Is that real?
No, I don't think it's time. Well, it might be. I don't know.
I didn't think it out at 6.2.
So then we're going to take this like this and evaluate that. And when you evaluate that, you should get 3/2 minus 0, which is 3/2. So this becomes 3/2 minus 0, which is 3/2.
Sarah.
Okay?